This is the first video of a series looking at simultaneous equations. In particular, this video will look at how to solve them graphically. But let's start by looking at what a simultaneous equation is. Now, equations may have more than one variable and more than one solution. There may also be several equations involving the same variables. Now, these are called simultaneous equations. We're going to be looking specifically at linear equations with two variables and two equations. So this is where we're finding our x and our y. So note that a system of equations may also be three equations of three variables. So the number of equations needs to match the number of variables that you're trying to find or the number of unknowns. Now, solving simultaneous equations involves finding a solution that satisfies both equations. Now, the solution to linear simultaneous equations is going to be the point where the graphs intersect. So if you have two straight lines, unless they're parallel, those two lines are going to intersect at a point. That is what we're trying to find, the point of intersection. Okay, so when we're solving equations, we're trying to find that point of intersection. Now, lines that have the same gradient, as I just pointed out, are parallel and they won't have an intersection point. So if you have two parallel lines, they are never going to intersect, so they have no solution. Finally, we could have two lines that are identical. So our two lines are on top of each other. Now they're going to have an infinite set of solutions because every point on that line is also on the other line. So let's start with our first method, which is a nice visual way of seeing what we're doing. Solving graphically. When solving simultaneous equations graphically, obtaining an accurate solution depends on drawing accurate graphs. So it's not the ideal method of solution because we're going to be estimating. Now remember that you need the x and y intercepts to sketch a straight line or one other point if the line passes through 0, 0. So we're solving for x equals 0 being our y-intercept and y equals 0 being our x-intercept. So this is a good review of sketching linear lines. So let's look at the first example. Solve the following simultaneous equations by graphing. So we start by finding our x and y intercepts. If we are looking at our first equation, 2x minus y equals 4, we start by letting x equals 0. So we've got two lots of 0 minus y equals 4. So negative y equals 4. So y has to be negative 4. So our first point is 0, negative 4. We then go, well, what happens when y is 0? We're finding our x-intercept. So 2x minus 0 equals 4. 2x equals 4. We would divide both sides by 2. So x is 2. So that's the point 2, 0. So when I come to sketching this, I've got 0, negative 4 as one point and 2, 0 as the other point. And I would then join a line between those 2 points. So once you have your line, make sure you label it, especially when we're putting more than one line on the one graph. So now let's do our other equation. So start with x equals 0. So we've got 0 plus 2y equals negative 3. Y equals negative 3. Sorry, 2y equals negative 3. So divide both sides by 2. So y equals negative 3 over 2 or negative 1.5. So our first point is 0, negative 1.5. We then find the x-intercept, so y is 0. So we've got x plus 2 lots of 0 equals negative 3. X equals negative 3. So we've got negative 3, 0. Go to our graph, 0, negative 1.5. Try to be accurate. And negative 3, 0. And then join those two dots. And remember to label your line. Now we need to find the point of intersection, which you can see here. And my graph is fairly accurate. So solution is 1, -2. Or if you wanted to, you could write it as x equals 1, y equals -2, whichever option you want. Now try and do this one on your own. Pause the video, give it a go yourself, and don't just look at what I'm doing. Okay, so pause the video, do it yourself, check your solution, and then you can move on to the exercises. So let's start with the first one. If x equals 0, y is going to be 3 lots of 0, which is 0. So it goes through 0, 0. So this is when I have to find one other point. So if I let x equal 1, y equals 3 lots of 1, which is 3. So the point 1, 3. Remember, I could find any other point, and we only have to do this when our graph goes through 0, 0. Put your dots on, join your 2 points. Once you've joined your points, label your graph, y equals 3x, and then move on to the other one. So x equals 0, we've got y equals 4, because 0 plus y. So we've got 0, 4, and then y equals 0. So now we're going to have x equals 4. So that's the point 4, 0. So go to your graph, we've got 0, 4, and 4, 0. Don't forget to label your line. And you can see the solution. Remember to always state your solution as either a coordinate or stating each point. Now with the two that we've done here, it's been quite easy to see the point of intersection, but I think you'll understand that graphing is only as accurate as what the solutions are. So if our solution was 1.2 and 3.5, it's not going to be very accurate with graphing, and we're going to be estimating our answers. So graphing is not the ideal method of solving simultaneous equations. We'd usually do it algebraically so we can get an exact answer. So your task now is to practice exercise 1I, page 53, questions 2 and 3.